Hello, welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video, we'll look at checkpoint 6.8 coming from section 6.2. It says to differentiate the series, this is for the function 1 over 1 minus x quantity squared in the denominator, which is equal to this series n goes from 0 to infinity of n plus 1, and that is also to the x times x to the nth power. And then it says term by term differentiation to find a new power series representation for this new function, 2 divided by 1 minus x cubed, which I'm assuming is the antiderivative of this original function. So let's verify that. I guess it's always good to check to make sure that that's actually true, that if we take the ddx of this function that we have up here, that's 1 over 1 minus x quantity squared. I would probably want to write that as x minus 1, or 1 minus x, sorry, to the negative 2 power. And let's follow the rules. This is going to be negative 2. And then you have 1 minus x, subtract 1 from here, so negative 2 minus 1 is negative 3, and times the derivative of the inside will be an extra negative 1. So yes, this is in fact a positive 2 in the numerator and a 1 minus x to the third in the denominator. So that is in fact what we have. All right. So in our differentiating, we will get, so it's the ddx of 1 over 1 minus x quantity squared will equal to the ddx of this series, and goes from 0 to infinity of n plus 1 times x to the nth power. It turns out that properties of the derivative of the sum is the sum of the derivatives, so it's like piecewise differentiation, which makes the series nice to work with in calculus because we can just take the derivative term by term. So that's a term by term differentiation. So you are really looking at going from 0 to infinity of ddx of n plus 1 x to the nth power. All right. And if we do that term by term, then we can figure out what's happening inside. N plus 1 is a constant, and so the derivative of x to the n is just going to be n times x to the n minus 1. So by taking that derivative inside, this will be n plus 1 constant, and then the derivative of x to the n is going to be n x to the n minus 1. So that would be it. Now, just as a side note here, we're going to realize that if we put n is equal to 0, this is going to be n, or 0 plus 1, so that's going to be 1. This is going to be 0, and this is going to be x to the negative 1 power, which technically is not going to be a series anymore. But wait, this is equal to 0 because this whole thing is equal to 0. So at n is equal to 0 is not going to matter for us. So I can rewrite this as the series n goes from 1 to infinity of n plus 1 times n times x to the n minus 1. You can leave your answer like this, or you can go, if you really do want to start from 0, then we can do an index shift, and an index shift allows us to start at the right place. And to do that, I generally want to check what happens when I put 1 in here, the leading term, and then 2, 3, and see what happens. So if I put 1 in for n, I will get 2 times 1 times x to the 0 power, and I'll not simplify it. I'll just write it kind of raw like that. And then the next term would be 2, so 2 plus 2, or 2 plus 1 is 3. times 2 times x to the 2 minus 1 to the first power, and I'll just put dot 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 there. So in terms of the index shift, the general rule of thumb is that if you want to subtract 1 from the starting point in n, then you would add 1 to the other point in here. So I would probably think about adding 1 here. So this n plus 1 plus 1, so it's going to be n plus 2, and then this will just become an n plus 1, and then this will be x to the n plus 1 minus 1, so that's just going to be the nth power. All right, so if you're comfortable with this, then this is what you would get. If you want to double check, as you should, let's try putting 0 in there to see if we get the same thing that we got in the previous sum. So if we put 0 in there, we're going to get 2, we're going to get 1, and then x to the 0 power. That's a good sign. When we put 1 in there, we're going to get 3, and then 1 plus 1 is 2, and then this will be x to the 1 power to the first power. So it looks like it checks out, and these two things are in fact equal. And this is good to do it this way because now you want your power series to have x to the nth power, and then you can adjust your starting point as needed. All right, so that's it. I hope that helps, and good luck.